In this question, we're given a regular hexagon, and we're told that it lies on the Cartesian plane. And we're also given the equation of two of the lines of symmetry that would pass through this hexagon. One is at x equals -2, and one is at y equals 3. So we want to know the order of rotational symmetry of the hexagon and where it will be located. So I'm just going to label the vertices of this hexagon for the purpose of explanation. So it's A, B, C, D, E, and F. Now, if we were to start rotating this hexagon about its center, we notice that all the points I've labeled here are the same distance apart. So if we start rotating it around its center, what we'd find is that after some of a rotation, that A would end up where B is. If we rotate it again, then A would end up where C is. We could rotate it to end up where D is, and so on all the way around that circle, or around this hexagon, in a 360-degree rotation. So after one complete rotation, we would find that point A would actually line up 6 times all the way around. So our order of rotational symmetry is 6. Now to determine what quadrant this would be located in, let's just draw a rough set of axes over here to the side. So we have x here, we have y here. Now, recall we have 4 quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now in quadrant 1, both coordinates are positive, both x and y. In quadrant 2, we've got a negative x coordinate and a positive y coordinate. In quadrant 3, we've got a negative x and a negative y coordinate. And in quadrant 4, we've got a positive x coordinate with a negative y coordinate. So if we have two lines of symmetry, one at x equals -2, it means we've got a negative value for x, and we've got a positive value for y at y equals 3. So we're looking for a combination of negative x, positive y, and that's located right here in quadrant 2. So our answer for this question would be